Hi, good morning, good afternoon, good evening, ladies and gentlemen, depending on where you are in the world. My name is David Crouch, and it's a great pleasure to introduce you to today's European section virtual webinar on respirable crystalline silica. We're going to run through the presentation. In terms of an introduction, we've got three keynote speakers today. Explaining the basics around respirable crystalline silica, controlling exposure, and then at the end, we have a case study on the UK H2S transportation project. So first, we're going to start with Tina Conroy from Pragma and Associates on what is respirable crystalline silica and where is it used. And then today, we're going to roll straight into our second presentation without questions because our two keynote and then Chris Keane is going to talk about controlling respirable crystalline silica exposure from a health and safety perspective. And then at the end, we will have questions, and then we'll move into Eric Ball from Park Heath, who has kindly agreed to give a presentation on a major transportation project, the HS2 project, which is a new railway infrastructure project in the United Kingdom. And then we will have further questions at the end. So in terms of, for those online who are not aware of the International Society for Respiratory Protection, what do we do? Who are we? We're a non-profit organization whose charter is to provide education and information to all individuals involved in respiratory protection. We have 6 sections, of which the European is one. We have the Americas, Australasia, Japan, Korea, and Greater China. And we all have the same objectives: to enhance health and safety of persons that use respiratory protection devices, encourage the development of standards, best practices, and to promote research and evaluation in respiratory protection. And we also encourage the exchange of information amongst a wide range of stakeholders: government, industry, organized labor, education, manufacturers, and other professional organizations, which moves me on to today's program. So firstly, I would like to thank the British Occupational Hygiene Society for providing 2 of today's keynote speakers, in Tina and Chris. And the idea of the education program is to introduce attendees to the role of respiratory protection against a range of airborne hazards, depending on the topic within the individual webinar. So at the end, the attendees will be able to appreciate the types and risks and pathways and symptoms of the particular hazard, and then understand what kind of RPE measures need to be included. And then we like to include best practice and case studies from the real world. So without further ado, it's a great pleasure to introduce our first speaker, Tina Conroy, who is an occupational hygienist from Pragma and Associates. So Tina graduated from the University of Sheffield with a master's degree in chemistry before gaining many qualifications in the field of occupational hygiene and achieved a fantastic status of chartered British Occupational Hygiene Society in 2015. She's had more than 15 years experience in occupational hygiene, working across a vast range of areas within industry, such as the steel and chemical industry. And since 2021, she's been leading the BOHS's Breathe Freely in Construction campaign. So without further ado, Tina, I will pass the webinar over to you.
Thanks very much, Dave. I'm going to share screen and hopefully, bear with me one moment. Which will be successful. There we go. Well, thank you very much for allowing me the time to speak today. What I'm going to try and cover is looking at occupational lung disease in its entirety to some degree. In specific, where does RCS, respirable crystalline silica, fit into this picture? Where will we come across it, and what are the kind of issues that we see from exposure from it? So just to kind of put it in the context of the bigger picture, This slide kind of represents the scale of occupational lung disease in the UK, and I think the numbers are just astounding. And these are just reported figures. So we're looking 17,000 new cases of self-reported breathing or lung problems, 135,000 people who ever considered that they've got breathing or lung problems because of work, and 12,000 lung disease deaths each year estimated to be linked to past or present exposures at work. Just to put that kind of figure into context, a commercial aircraft, such as those that would transport us around our holidays, they're designed to carry up to about 450 people. So if 2 plane crashes occurred a month and killed everybody in them, that's the kind of scale we're seeing of lung disease deaths caused by exposure in the workplace. And let's be honest, who's going to get on a plane if 2 a month are going to come down? Historically, it has been heavily dominated by exposures to asbestos, so looking at mesothelioma, asbestos-related lung cancer, but that's starting to shift now, and we're not seeing significant reduction in numbers. So one of the causative agents that does contribute to those figures is exposure to respirable crystalline silica, RCS. Now, silica is a natural material, natural mineral. It's quite ubiquitous to the environment. We've got 95% of the Earth's crust made from materials containing silica, and it has properties that do make it very valuable in our industry. So it's hard, it's chemically inert, high melting point. We find it in bricks, glass, food additives, toothpaste, electronics, and day-to-day uses. There's no evidence to support that it's going to harm us. However, when we're actually manufacturing and we put a lot of energy into it, so processes such as cutting, drilling, grinding of these silica materials, we start to produce very fine dust that can get into the deep lung and cause issues. And this is the main concern. And you've got to bear in mind that there isn't a safety data sheet for this. So all those employers out there, they've not got this 2-hand piece of paper that says this is a problem. This is a byproduct that we create. So we need to up the information to them, and we need good employers to go and find that information themselves. And the main health effects of concern are silicosis, lung cancer and COPD. In relation to crystalline silica, you can get amorphous silica as well. Amorphous tends to be less hazardous, but it can still contribute to fibrosis. So for amorphous, you're looking at things like diatomaceous earth, opal, flint. Problem with the crystalline silica, you can see there is a picture on your, I think it's on your right hand side, but it might not be, I might be the other way around. And that shows you how small the particles are in comparison to a human facial hair. So you get a lot of very fine particles there. Silicosis, serious irreversible lung disease. It can, people with lung cancer can, with silicosis have a higher risk of developing lung cancer, and COPD, so bronchitis, emphysema, that can result in severe ill health, so breathlessness, prolonged coughing, chronic disability can lead to death. Once silicosis or COPD has started, even if you remove somebody from the exposure, you can still get progression of the disease. So how does that lead to, what's the big deal? Well, just to kind of put figures to it, so an estimated 600,000 workers were exposed to silica in the UK, or that was the estimated figure based upon a report in the Lancet in 2012. Health and Safety Executive estimates that about 600 deaths per year are caused by lung cancer, just lung cancer associated with exposure to RCS. And when you think about the other diseases, the COPD, the silicosis, we could be looking at potentially as high as 1,000 a year. So that's 2 planes worth of holiday makers dropping from sky every year. And every single death that's caused there is completely preventable. And okay, there can be a bit of a latency period between the cause and effect with RCS and ill health. And I appreciate that to some degree, people developing pulmonary disease as a result of historic exposures. Some might have happened over the last 10 years, over the last 20 years, over the last 40 years. So surely we need to concentrate on now. But the truth of the matter is, exposure to silica dust was actually among one of the earliest recognised occupational disease hazards. So even the Greeks and the Romans recognised that miners, workers involved in extricative work, they suffered from lung disease. And then there was a range of medical literature until a physician called Achille Visconti coined the term silicosis. That's from the Latin silex or flint. Today we call it RCS, Respirable Crystalline Silica. And the relationship between exposure to silica dust and pulmonary disease, it was referred to extensively throughout the early 20th century. Just to give an example, in the 1945 HMFI report, it's their annual report. They were the regulators at the time, precursor to HSE or pre-HSE. So 1945, they referred to it in the context of a well-recognised poisonous dust that it was common knowledge that injury might arise from. There's been numerical standards in place since 1960, and there's been applicable legislation and guidance probably from even before that time. 1970, we standardised to look at the respirable fraction. So that's 50 years at least of knowledge and information. So yes, they are historic exposures to some degree, but it's 50 years and we're still not seeing significant improvements in that. Oh, apologies. Just to kind of put it into where you might find RCS, as I said, it's quite ubiquitous in the atmosphere, in the environment. Lots of natural materials contain crystalline silica, and that's just some of them. Very different in the makeup. Contribution to the material matrix depends upon which material you're working with. So where might you find it? Looking at the list of materials we just had, construction is the obvious place. And there are significant numbers of people who are exposed to RCS in the construction industry. And it makes sense when you think about the work, the range of activities, the materials that we work. And of course, these days, there's a lot of reliance for obvious reasons on powered machinery and tools. Problem with these is they do generate more dust than what your standard hand tools do. And there's a lot of literature that publish measured concentrations of RCS generated from work such as shown in these pictures. Just to give you an example, cutting a concrete paving slab using a still saw without any control in place, you can get concentrations, and this is just single concentrations, up to about 70 milligram per metre cubed. So we're talking more than 500 times the current workplace exposure limit, which we'll come on to in a little bit. So if you imagine that, and our current workplace exposure limit is 0.1, if somebody does that task for a couple of minutes, they're probably out well over the exposure, the workplace exposure limit. And I'd like to say, yes, we don't see this anymore, but even in the last couple of months from watching TV, I've seen examples of people cutting paving slabs, funnily enough, using still saws. So it does unfortunately still happen. Other industries, stoneworking, covers a wide area. We're looking at stonemasonry, restoration work, sculpting, so your artists, manufacture and fitting of artificial stone, which has seen quite it's becoming increasingly popular in current day kitchens. And that artificial stone can contain more than 85% crystalline silica. So potential for exposure, very variable depending upon the materials and what is being done. But there is literature that supports that there's a potential for exceedance of the current workplace exposure limit, and potentially significantly so. Quarrying. And when it comes to quarrying, exposure to RCS is one of the main health concerns for quarry workers. And historically, it's been an industry that has influenced the setting of an exposure limit. So just to put that into context, in 1989, there was a recommended limit proposed at 0.1 milligram per metre cubed, which is what it is today. However, after discussions with industry, it was noted that there's going to be difficulties in compliance with that in quarrying. And for that reason, it was set at 0.4 at that time. I think the scale of operations reflect the potential scale of exposures that might occur there. Just out of interest, it was noted in that when that 1989, as it was at the time, a maximum exposure limit was set, that all other industries should be able to comply with the 0.1. Brick making. Just looking at that table we went back to, bricks can contain, I think that's at up to 30% crystalline silica. I think it might be up to 40% crystalline silica. And it's really useful in bricks because it prevents shrinkage during the process and manufacture. So you can see its benefit in there. And bricks are made from relatively soft sedimentary rocks, and we crush them, we grind them, we mix them with water, we mold them into bricks, and then they're fired. So you can imagine the crushing, the grinding, potential for high dust exposures at the clay preparation side. And also you might find that dressing and parting powders containing silica is used. And then during a process known as dehacking, which is the removal from the kiln and the handling of it, where any loose dust present might then be made airborne. And with all of these industries as well, cleaning and maintenance. And cleaning and maintenance is something that often gets forgotten when we look at exposures. Foundries. A lot of foundries still use sand as a moulding medium. Sand does contain crystalline silica, not generally respirable crystalline silica, which is why we don't have a problem on beaches and such. Different type of sand, but issues come when we work with it. So silica dust you can encounter at different points throughout the foundry, namely sand plants, if it's reclamation or recycling, knockouts, so when you take the cast out and it's still coated, and shakeouts, and then you go to the fettling where everything's taken off the surface, all the imperfections. And again, in addition, you've got things like maintenance repair tasks. RCS can be used for lining ladles, furnaces, cupolas. So during relining activities, you can find you do get quite high exposures. And also for very similar reasons, potteries and whiteware. So you can get high dust concentrations from mixing of clay and associated activities, and from tipping, scooping, casting, fettling, same as in the metal industries. So what's the problem? So you've just seen those pictures, and each of those pictures gives you an overview of the kind of dust levels that you're looking at, or that you might find, not that you necessarily will, but you might find in industry, especially without any controls being in place. Well, currently in the UK, there's a workplace exposure limit of 0.1 milligram per metre cube as an average over 8 hours. It is not a safe limit. There, as far as I'm aware, there has never been a level of exposure below which adverse health effects are identified as not occurring. Now, what we've got here is some statistics as to, so that limit 0.1, what does that mean in reality? Well, estimated 2.5% of workers who are exposed to that for only 15 years are likely to go on to develop silicosis. So for every 100 person in the construction industry who stays there for 15 years, which is a very realistic scenario, two and a half of them, so 2 to 3 of them are going to go and become ill. When you class that into the thousands that work in the construction industry, that is a lot of people at risk. After 45 years of exposure, that increases quite significantly. And during the 1990s, 30% of general construction workers were exposed to more than 0.3, 65% more than the 0.1. So it's potentially a lot of people who could be affected by that. Just to kind of, what does it look like? Just try and put it into context. So there's 5p piece there, RCS dust. If that was in a 1 metre box, so 1 metre cube box, so about top of your legs, that kind of size box, that would be enough to get you to the workplace exposure limit. So if that amount were kept being put in, and that, so additively wise, if you imagine a teaspoon of silica dust weighs about 4 grams, and your average human at moderate activity breathes in of the order of 16 to 17 meters cubed of air over an 8-hour period, and they're not my figures, I've actually had a Google search them, so don't hold me accountable, please. But if that was accepted to be true, 1.6 milligram as a total, so if you had a spoon with 1.6 milligram, so it works out at being 1/160th of a teaspoon. If they inhaled that, They'd be over their whole 8-hour time weighted average, even if they didn't have any further exposure. So I think it can happen without this kind of level of exposure, can happen without it even being noticed. You don't have to have a room full of silica dust that you can see in air. In fact, chances are you're not going to see it rather than you are going to see it. And if you look at the photos, consider the photos earlier, what kind of levels are they? If you can't see 0.1 milligram per meter cubed. So at this point, I'm going to pass over to Chris, who can answer the question of what should we be doing about this. Thank you.
So many thanks, Tina. Just as Tina's excellent presentation is finished, I just want to, before we move on to introducing Chris, if anybody has any questions for both speakers when we finish at the end of Chris's presentation, if you would like to put your questions in the Q&A box at the bottom, that would be fantastic. So moving on, I'm just going to now introduce our next keynote speaker, and it's a great presentation. It's great to introduce Chris Green from the Health and Safety Executive, but Chris is involved in many things. He's Principal Occupational Hygienist at the Health and Safety Science and Research Centre in Buxton in the United Kingdom, and she leads a team across a diverse range of professional hygienists looking at many different areas. And in collaboration with BOHS, which is part of today's webinar, she's also a chartered member of the BOHS Faculty of Occupational Hygiene, and she is their current president. She's got over 35 years experience in measuring and controlling health risks within the workplace, and I don't think I could think of anybody more suitable to talk about controlling RCS exposures. So with that, Chris, I will pass the floor over to you.
Thanks to Tina for setting this up. Yeah, I'm going to talk about how to control silica exposures. I've titled this presentation, Controlling Exposure, Managing Risk, Protecting Health. We're controlling exposure because it's desperately important that we protect the health of people working with respirable crystalline silica. Tina's already told us what it can do to people. It causes a huge amount of harm. Internationally, I think it's the single agent that's responsible for the biggest burden of respiratory disease across the world. The figures that Tina was giving you for the UK only, if you multiply that up internationally, it's harming tens of thousands, hundreds of thousands of people. Okay. Within the UK, I'm going to use the cost regulations, the UK cost regulations, as a framework for talking about exposure control. Forgive me if you're overseas and you've not got the cost regulations, but they provide me with a framework to talk around. And the principles that are set out in the cost regulations are the general principles of good control practice in any case. So you should be familiar with what I'm going to say here. What I will say is it's certainly within the UK, from a regulatory perspective, the cost regs are the thing that we tend to focus on the most. It's not just the cost regs. We've also got the construction, the CDM regs, which place responsibilities on duty holders to control risk. We've got the management of health and safety at work regs. So it's not all about one particular set of regulations. I'm using COSH because it provides me with a framework to talk about. So within the COSH regs, we've got Reg 6, which talks about risk assessment. I'm not going to go into risk assessment in great detail here because I've not got time. We've got Regulations 7 and 8, which talk about the duty to prevent or control exposure. Reg 9, maintaining controls. Regs 10 and 11 are about checking the efficacy of controls, making sure that your controls are working, and I will touch on them a bit later in the presentation. And then Reg 12 is about providing your workers with adequate information, instruction, and training to keep them safe. So I'm not going to talk about Reg 6 risk assessment, I've not got the time. I'm going to go straight to COSH Regulation 7, because that is the heart of the COSH regulations as far as I'm concerned. This is where we have a duty to, the primary duty is to prevent exposure to hazardous substances. So if you can prevent people from being exposed in the first place, that's what you must do. If that's not possible, which is generally not the case, if we've got people working in construction industry or in other industries with silica containing materials, then the duty is to adequately control exposure. The COSH regulations lead us to apply the hierarchy of control, and you're probably familiar with the idea of the hierarchy of control. I'm going to touch on that in a couple of slides' time. And the cost regulations specify 8 principles of good control practice. And the legal duties under COSH, the primary legal duties under the COSH regulations, are to control exposure in accordance with these good control practices. Yes, we have an exposure limit, and there's also a duty in COSH to control to below the exposure limit. But the exposure limit, as Tina's already said, is not a safe limit. There's still a residual risk for people that are exposed at that level. And controlling exposures to silica or to any other substance using the exposure limit as a safe limit is not good control practice. You must be below the limit, but the real responsibilities are to implement the principles of good control practice and to apply the hierarchy of control. You probably are familiar with the hierarchy of control, so I'm not going to talk about it for too long. You can see a representation of it up on the slide there. So at the top of the hierarchy, we have elimination. If you can take a risk out of the system altogether, if you can get rid of it completely, then obviously it's not going to harm anyone. Okay, we work down the hierarchy to a substitution. And as we go down the hierarchy of control, we get into control solutions that are less and less reliable, more and more likely to fail in the workplace. So at the bottom of the hierarchy of control, we have PPE. I'm sure as PPE experts, a lot of people on this webinar will already recognize that, PPE is the bottom of the hierarchy of control. I'm not saying that PPE is not effective and doesn't have a part to play in controlling silica exposures, because it most certainly does. But it is less reliable than the control options above it in the hierarchy. And we should keep that in mind when we're designing a risk management strategy for respirable crystalline silica. So I'll touch on elimination and substitution now. They're the top of the hierarchy. As I said earlier, if you can eliminate a hazard from a system, then it doesn't represent a risk anymore. So if you can find a way of doing the work that you need to do, not using silica containing materials, then that is obviously a very, very, very effective way of totally removing the risk. That's easy to say. It's not at all easy to implement. Okay, if you work in construction or in many of the other industries where we have a silica hazard, it's going to be very, very difficult to find non-silica containing alternative materials. There are some available. There are some available and have been for many years in construction. Things like plastic curbstones are available. They are worth investigating, but they are not that common. As the construction industry develops and the technologies that are used in the construction industry develop, I suspect we will see an increase in incidence of silica-free alternatives starting to appear in the industry. And we should always keep in mind, if it's possible to use one of these materials, then we need to give that serious consideration. Okay. Assuming we can't move to a totally silica-free alternative, then the next step along the hierarchy is to think about the silica content of the materials that you're handling. So as Tina's already said, the silica content in construction materials can vary wildly. Even in sort of masonry materials, you can get anywhere between 5% and 90% silica in the bulk material. So if possible, look to be using as low a silica content of material as you're able to use, okay? Because obviously that then reduces the risk proportionally. If you can drop the silica content of your raw materials from 90%, 20%, then you're going to, quarter the exposure risk for people that are working with those materials. It's not just about the raw materials, because on their own, they don't represent a hazard. A pile of house bricks or a pile of sand doesn't represent an inhalation hazard as it sat there on the ground. The problem comes, as Tina's already said, is when you start to work these materials, and particularly when you start to work these materials using high energy processes. So think about the tools that are being used. Is there a different way of processing the material? A simple example is cutting paving stones, paving slabs. Is it possible to use a guillotine rather than a spinning disc cutting, a cut-off saw? If that's possible, that will generate much, much, much less dust. So if you can't get silica out of the raw material, think about the way it's processed. Think about using lower dust generating handling methods, lower dust generating tools. An obvious one, but we still see a problem with this, is simply to reduce the numbers of people exposed. So if you are generating silica dust, if you've got processes which generate dust, you shouldn't have non-essential workers in that area. And we've all seen construction sites where someone's working with a cut-off saw and there'll be other people working in the same space who will be receiving secondary exposure to silica as a result of that cut-off saw activity, okay? So if you are generating dust, if you can't adequately control the dust emissions from the process using engineering controls, which I'm going to come on to next, then you should only have essential workers in that area. Job rotation, in my opinion, is not a great exposure control, okay? If you've got something like silica, which causes irreversible harm, it causes cancer, potentially causes cancer, it is a lung carcinogen, okay? Then not applying good standard of engineering control and just rotating the job around, getting more workers to each get a little bit less exposure is not a great control philosophy. The overall risk associated with doing the job, if you take that route, is just the same. Yes, each individual worker gets a lower dose of exposure, but you're just spreading that exposure amongst more workers. So you're not reducing the risk at all. And it's not a great control, certainly for things that cause irreversible harm like silica. The next few slides, I'm moving down the hierarchy of control here. I'm going to talk about engineering controls. I'm going to start with water suppression, because water suppression can be a really effective exposure control solution for many, many processes and activities where we see silica as a hazard. Used properly, effective water suppression systems can reduce exposures by over 90%, by over 95%. They'll never be 100% effective, but they can be very, very good at reducing dust emissions from processes. I've said on the slide that they're cheap and relatively easy. I mean, there is a cost associated with them. There are technical issues that need to be addressed if you're going to implement water suppression as an effective control. But compared to things like ventilation, local exhaust ventilation, I would argue that water suppression is cheap and relatively easy to implement as an exposure control, okay? Obvious point that needs to be made, if you're going to rely on water suppression to control risk, you're going to need enough water to be able to apply water suppression at all the points that it's needed in the process. And I've seen many, many situations where I've been out on construction sites where water suppression is available, but it's not being used. And when you ask people why they're not using it, it's because it's being used somewhere else on the site. They've only got a single water supply. They've got multiple tools that need water suppression, and they don't have the capacity to supply it to all the tools at all the times. Okay, if you're relying on it as an exposure control, it needs to be available at all times when the tools are going to be used. And if for some reason the water supply isn't available, don't use the tool. The job needs to wait and be done later on. It's not good enough to just pick up the tool and spend 5 minutes working on it if the water suppression system is not available temporarily. Because as Tina's already said, 5 minutes of exposure using a power tool with no dust control on it at all can be enough to take you over your daily exposure limit. And obviously water suppression might introduce other hazards as well. It's probably not a great idea to use it on electrically powered equipment. It can introduce slip hazards. You can get ice from it in the winter. It's not a panacea, but it can be a very effective control solution for silica. LEV, local exhaust ventilation systems. We see these used in manufacturing environments. They didn't used to be that common in construction. They are getting increasingly common in construction. Again, they can be very effective in controlling dust emissions. I would argue that they're probably not as effective as water suppression systems, but a good LEV system can capture 70, 80, and 90% of the dust from a process if it's set up properly and used properly, okay? One of the big problems with controlling silica dust is it's generally being released with a very high energy from a process. So if you think about a spinning cut-off saw, you've got a blade spinning at 2,000, 3,000 revs per minute, okay? That is throwing out a plume of dust with a very high energy in a particular direction. And that can be particularly difficult to capture into an LEV system. So you're going to need a well-designed system to capture these high energy dust emissions from construction processes, okay? As I say, LEV can be quite tricky to get right. And I would suggest that if you're not sure what you're doing, you're going to need some competent advice in selecting and designing an LEV system for your process. Don't try to do it by guesswork. Seek competent advice, and you can get that through BOHS. You can get it through ILEV in the UK. I'm sure there are other organisations internationally that offer that level of advice. Okay. And my final point on LEV systems, I think users often overestimate how efficient they are. So they think they've got an LEV system in place, that's it, they've ticked the box, they're controlling risk. If the system's not being commissioned properly, if the system's not maintained, if it's not used properly, there's a very high chance that it's not giving you the level of protection that you think it's giving you. And users often really significantly overestimate how effective their LEV systems are. So don't fall into that trap. A quick slide about on-tool extraction. I don't profess to be an expert on this, but 15, 20 years ago, on-tool extraction systems were fairly rare, and the ones that were around weren't particularly user-friendly, weren't particularly practical. That's not the case anymore. We see some very, very effective on-tool extraction systems available these days. I mean, I've got up on the slide there, I think that's a piece of Hilti kit. I'm not advertising Hilti's equipment. All the big power tool manufacturers, Makita, DeWalt, will all increasingly providing some very innovative and very effective on-tool extraction solutions for working silica-based materials. They're worth a look. Again, they can be very effective. You're going to need an effective filtration system. You can see the portable vacuum cleaner that the tool's hooked up to there. But certainly they are increasingly useful in construction. We're seeing them more and more these days. Cab filtration. It's not always recognised that you've got an exposure control available to you. If you've got people working in cabs, such as in quarries, where there'll be very few ground workers, most people will be inside a vehicle, then if you've got an enclosed cab on that vehicle and install a decent filtration system onto that cab, you've potentially got a very effective exposure control. Okay. My colleagues up at the HSE research labs where I work in Buxton have done some research on this. You can see research report 1126 if you want to find out more about cab filtration. And we've got in the UK some Kosh Essentials guidance on cab filtration. It's worth a look. It's worth thinking about. As I say, if you've got people inside vehicle cabs and you've got an aircon system on the cab that's got a filter in it, it can be a very effective exposure control. Just to labour the point, which I was making a couple of slides ago about engineering controls. Okay, it's not enough just to buy an off-the-shelf LEV system, stick it on your process and assume that you are protecting your workers, because there's a very high chance that something will have gone wrong in that process. Systems need to be designed properly in the first place. The design needs to match the process. It needs to match the workplace. They need to be installed properly and commissioned. Crucially, if you must commission an engineering control. Once you've put it in, you need to do some tests, whatever that might be, air sampling or whatever it will be. A decent LEV engineer will understand how a system should be commissioned to ensure that it is working properly. You need to train your workers to use it properly. And I've seen situations where workers didn't even know how to switch LEV systems on. So the system's available, but they can't even find the on-off switch when I've challenged them. And then they need to be maintained. These are harsh environment. Quarries, construction sites, brickworks, these are harsh environments. And things like LEV systems are going to get knocked about, they're going to get broken, they're going to get damaged. If you don't adequately maintain these systems, there's a very high chance that within 2 or 3 months of installing them, they'll be useless, they'll be broken. On the hierarchy of control now, and I recognise I'm talking to an audience here that's largely sort of PPE line of defence, okay? Yeah. It has numerous failure modes, and generally speaking, it always has a slide there. My colleague took this. This was a guy who'd been cutting roof tiles on a construction site. He'd been cutting roof tiles for less than 10 minutes, and you can see around his nose there, both sides of his nose, and coming down to his top lip, you can see a little brown line. That's silica dust that's got around the edge of his mask. That's a poorly fitting dust mask. That guy thought he was protected and he wasn't. PPE very, very often fails, and it can introduce other risks such as heat stress. Communications are difficult if you're wearing a dust mask and you've got safety critical communications. They can be very difficult. And compatibility with other PPE. So if you're expecting workers to also wear hearing protection, hard hat, eye protection, that's a lot of kit that they've got around their head while they're trying to do their job. So I'm not saying that PPE, that respirators and dust masks don't have a part to play in controlling silica exposure, because they very, very, very definitely do. Okay, but they should be there in addition to a decent set of engineering control. They are not there as the primary exposure control. We shouldn't be relying on PPE, on dust masks, as the only line of defense against things like silica that can cause cancer and other irreversible effects. If you want to think about it like this is my attempt to use the Swiss cheese model. So you'll probably be familiar with the Swiss cheese model of risk control. What you need is various layers of protection, each of them represented by a slice of cheese. Each slice of cheese has got holes in it. That's the failure modes of that particular level of protection. If the holes line up, then you're going to have the high chance of an accident. If you're relying on PPE, on dust masks, as your only control against silica dust, then you've got one layer of cheese in that model. And that layer of cheese has got many, many holes in it. It's just a different way of thinking about it. As I say, I'm not saying that RPE isn't a useful part of the solution for controlling silica exposures, because it's absolutely essential in many applications. But it should be there as an add-on to the other controls to control the residual risk. I've said that LEV, water suppression, will never be 100% effective, and that is the role that PPE plays. It controls against that residual exposure, but it's not there on its own as the primary barrier. And it won't protect anyone against this kind of thing. This is a real photograph that we took on a real work site, okay? So this guy's been using a power tool, no engineering controls. Yes, he's wearing a respirator while he's using the power tool. Yes, he's protected as long as that respirator fits him and he's worn properly. He's protected while he's wearing the respirator. But his overalls, his work clothing are so heavily contaminated with dust at the end of that operation. And then typically these people will take off their respirators and go about whatever else it is they're doing at work, their other activities. They'll still be wearing these very, very heavily contaminated overalls. And you can be exposed at the exposure limit for silica just from walking around in a set of overalls that are covered in dust like this. You don't need to be doing anything else. Just wearing the contaminated overalls is enough to give you an exposure at the exposure limit. Tina's already said the dust's invisible. You wouldn't see this dust in normal lighting. You know, this has been backlit using a Tyndall beam, using a dust lamp, which we often use in workplaces to show people just how much dust they're generating. So you've got invisible dust in normal light, but if you can get them to stand against a strong source of light, such as a Tyndall beam, or just get them to stand in a shaft of light somewhere, part of their overalls, the amount of dust that comes out of them is just incredible. Just another reason why respirators alone are not the answer to controlling silica. I'm going to talk very briefly about exposure monitoring here, because there is a feeling out there that exposure monitoring is a substitute for control. It's not. Exposure monitoring is not a control. Exposure monitoring is a way of assessing the risk. It's a way of showing that your controls are working properly, but it is not a substitute for controlling the risk in the first place. There's no legal responsibility to conduct exposure monitoring. It's not a legal duty under the cost regs, certainly in the UK. It does have a part to play in managing risk. If you're not sure whether you've got adequate control, if you want to commission your engineering controls, then exposure monitoring can be a very useful way of doing that. If you feel you have a need for exposure monitoring, then you really need to get someone competent to come and do the monitoring for you. It's very easy to get it wrong. For silica, we're talking about monitoring the respirable fraction of a dust, so you need the right sampling equipment, and you need to be able to design the monitoring strategy such that you capture all tasks and activities. Tina's already said People often overlook things like cleaning and maintenance activities where you can get the highest exposures. And you need to then be able to interpret the results in the context of risk management. So if you consider that you do need exposure monitoring, then I would strongly recommend that you get a professionally qualified occupational hygienist to come and support you in that element. Health surveillance is another part of the picture. It's quite a complicated picture. Again, like exposure monitoring, this is not a control measure. This is just a way of monitoring your workforce to ensure that none of them are developing any symptoms of silicosis. Silicosis in its early stages is totally asymptomatic. People will not know that they've started to develop the disease. They won't experience any breathing difficulties, and they might stay like that for many, many years. Properly used health surveillance can detect the early signs of silicosis, and it then allows you to manage that particular worker and to ensure that they don't receive any more harmful exposures. But if you start to get cases of damaged lungs on your health surveillance program, then that points to a need to go back to the work process and revise the controls, because that's telling you that your controls are not adequate. And it's not enough just to take out the workers that are identified as having started to develop silicosis. You need to go back up, complete the feedback loop, and go and have a look at the exposure controls. And information, instruction, and training, a vital part of this. There's no point giving workers dust masks and giving them LEV systems and water suppression systems if they don't understand why it's important that they use them. So they need to understand the hazard, they need to understand the risk, and they need to be trained to use the controls properly. It's a very, very important part of controlling any exposure to any harmful substance, and it's often overlooked. Key workers trying to work out how to fit a dust mask or how to configure an on-tool extraction system. If you're going to invest in the controls, then also invest in educating the workers as to how to use them properly. So I think I'm coming to an end now. I've got a few summary slides to just work through. For respirable crystalline silica, effective control, unless you can eliminate the hazard altogether, which is not a viable option in most situations at the moment. It may well be in the future, but not right now. Then effective control is usually going to rely on a combination of measures, a combination of different engineering controls and RPE in conjunction. Okay. Always keep in mind the hierarchy of control. Too many people, too many duty holders, too many supervisors, managers default straight to dust masks as their only control measure. That is not good enough. You need to always have in mind the hierarchy of control. Common sense, but again, we see this over. It's vital to involve workers when you're designing an exposure control strategy. If we try to implement exposure controls that aren't practical, that get in the way of them doing the job or slow them down, make it difficult for them, then they're going to find a way of not using those controls. It's vital when you're doing your risk assessment and you're designing your control strategy to involve some input from the workers that are actually doing the job. All tasks are important. It's not just about the production activity, it's about cleaning, it's about the maintenance. You can get much higher exposures associated with cleaning and maintenance than you can from production. So you must consider all tasks when you're implementing exposure controls. All controls require maintenance. I've already said LEV systems, these are harsh environments. LEV systems and respiratory protective equipment, if they're not looked after properly, if they're not maintained properly, then they are going to fail sooner or later. So implementing an effective control is just part of the process. It must then be looked after using a well-reasoned preventative maintenance program. And tell the workers, tell them what they need to know, tell them why it's important that they use the controls, and crucially, tell them how to use the controls and how to identify any situation where the controls might start to fail. So give them the information that they need to keep them safe. There's tons of information out there on controlling respirable crystalline silica in construction and in different industries, in brick making, in ceramics, in glass making. There's masses of information. Yeah, I'm talking today on behalf of BOHS, so I'm going to point you towards our Breathe Freely resources. They're freely available on the website. They're aimed specifically at construction. But HSE, as I say, there's a wealth of information out there. There's no excuse for not adequately controlling exposure, because for almost every application where silica is a problem, we do know the control solution. The problem is getting those control solutions communicated out into industry and getting them effectively implemented. And I think that's all I want to say today. Thank you very much for listening to me, and I think we're going to move to some Q&A. Is that right, Dave?
Yes, it is. Many thanks, Chris, and firstly for Tina for setting the scene of what RCS is, and Chris to follow up with such an excellent and very detailed presentation on kind of controlling the exposures. Lots of questions in the chat, so I'm going to start with Tina to start with, and this is a joint question that it's along similar lines from Joanne and Cynthia. So does silica disease progress even after exposures have kind of dissipated? And on top of that, from Cynthia, is it safe to say that a single exposure can progress to silica-related disease or illness?
I'm not a medic, I do hold my hands up, so I don't know how authoritative I can speak on that topic. I think from the point of view of progression, fibrosis and generally will progress after silicosis. So I think if you've got enough deposition in the lung of silica, yes, you will see progressive, and there's plenty of literature that describes how that can be progressive. It will slow down if you remove, in my understanding, if you remove the exposure, you will slow down the disease. But once it's started, I think you can get progression of it even away from exposure. In relation to the safe, whether one exposure, the honest answer is I don't know, because it's interesting because there is no safe limit, but I'm not aware of a single exposure, unless it's, even if it was extremely high, a single exposure causing silicosis. I suppose it's a risk. The more you get exposed to, the higher the risk. There must be a point whereby the risk is potentially the same as the background population. And I think one exposure, you probably be right down at the low end of the risk.
Okay.
I'm not aware of it ever, of one single exposure resulted in, regardless of how high that is.
I think I would agree with that, Tina. I think, let's keep a whole of reality. I don't think a single exposure to crystalline silica is going to represent a lifetime risk to anyone. Even in cases where we see acute silicosis in people who are very highly exposed, you're normally talking about 6 months to 2 years for them to start to develop symptoms. So I wouldn't get concerned about a single episode of exposure. The problem comes when people have a single episode every day and tolerate that for a protracted period of time.
Fantastic, thank you. And a bit of a follow-on, it's just popped in from Melindo. Do we find RCS also in graphite production? Is that something you've come across?
It's not something I've come across personally, I have to be honest. I don't know is the answer, I'm afraid.
I don't know either.
We can look that one up for you, Orlando, and we'll put that in on the website as a follow-up question. So moving on, because there are a lot of questions around from Mary's put one through, so I'm going to pose this to yourself, Chris. We know that RP is at the bottom of the hierarchy of control as a last resort, but we do unfortunately see RP worn in many workplaces, for example, construction. RP may very well be needed in situations where the risk assessment indicates it's necessary to mop up residual risk. My question is, in these cases, should we and how do we convince these industries to adopt powered air systems instead of tight-fitting dust masks? And an assumption around this is construction workers are notoriously bearded, wearing stubble, so we should be avoiding pushing tight-fitting RP in this demographic. Yes, we have fit testing programs in place, but this has been in place for some time, and yet we have seen this impact on the ill health statistics for this industry.
Well, a lot there to unpick. I think the nub of that question is, how do we convince people to move to powered air systems? I don't know the answer to that. in theory, FFP3 dust mask will give adequate control in most situations, but recognising that they are failure prone. And, you know, my personal view, this is not a view from HSE or BOH. I reckon that in industries like construction and heavy manufacturing, where dust masks are being used, FFP type dust masks, I reckon if a quarter of the workers are wearing them properly and don't have stubble and have been properly trained, I reckon that's probably an upper estimate as to how many people are being protected. I think 25% at most. I've stood in factories where respirators are mandatory and I've counted how many people are wearing them properly. And it's, you know, it's way below 50%. I don't know how we convince the people that are responsible for managing risk in these environments to move to powered equipment. I agree, powered equipment is less failure prone. You're not relying on that tight face seal. You're not relying on people being fit tested or wearing stubble or whatever else it is. I've seen figures which suggest that it's not as expensive as people might think to switch from disposable to powered RPE. When you factor up how many dust masks you get through and how much each dust mask costs, and you're throwing them all in the bin at the end of the day, I think you need to build a financial case really that illustrates that to the user population, that it might appear that it costs a lot more to buy powered equipment, but if you're managing your RPE program properly, it will similarly cost you a hell of a lot in disposable RPE if you're throwing it away at the recommended interval. But I can't. There is no easy answer.
Could I add onto that?
Yes, sure.
Just simply because obviously my experience and where I work predominantly in major construction projects, we certainly see a growing trend to using powered air respirators, and it's a combination of factors. Simple knowledge and awareness at every level. So for major projects, it's quite easy in terms of we have quite a knowledgeable and aware client who has very exacting standards. These are big major projects, and so if you are a construction company and you win a big major construction project, that will influence your ability to win the next one. So you want to make sure it's done right, so you not only meet their standards, but you achieve those. So when I come to see a particular operation and I say, well, if that is what's going to happen, then you need to have powered air in place. It's kind of I'm these days pushing more and more against an open door. And they'll just say, fine, if that's what it takes to enable us to continue, then let's carry on. And the other thing I would add is an increasing awareness in the workforce themselves. You know, the more we do presentations like this, the more we do presentations to actual workforce and explain to them, these are the risks, this is what you're being exposed to. You know, if you don't do something about it now, you're going to be thinking in 15, 20 years time that you should have done something about it. Then they're coming back to us and saying, well, this isn't right. I'm wearing this dust mask. This is, you know, I don't need to be a genius to know that this is a dusty job. I expect a higher standard. So knowledge and awareness of what is out there, knowledge and awareness of the risks. It is a slow, steady process. Every single major project at least has like small little step changes in terms of improving it. But I can certainly say, at least in my regards, we're seeing powered air respirators being more and more common. I'm not going to tell you now that we absolutely nail it. We still do have people in tight-fitting masks. We still have people wearing tight-fitting masks while trying to have a beard. You know, this is still a battle we still have. That said, you know, it is getting easier for us. One thing I've experienced recently, however, is actually getting our hands on it. And this is one of the challenges, what with global chip shortage, you know, we found actually the demand outweighs the supply in terms of, you know, we want to get this in place, and we've been told by suppliers to be like, you're waiting 3-4 months before you're able to. So that's another challenge that we have at the moment, is that actually we're asking for more of these things, and they're not quite available as yet.
No, thank you for that, Eric. I'm just conscious because there are a lot of questions in here. I'm just going to take a couple more and combine them together. And this is from Robert and James, and it says, given the recognition that the current UK exposure limit does not represent a safe level of exposure, do you think there's an appetite from HSE to reduce the current RCS exposure limit? And James has followed on and said, whilst we have an 8-hour workplace exposure limit in EH40, is there any guidance on a short 15-minute short-term exposure?
Okay, I'll try to talk to that one first. So I work for HSE, so I'll declare an interest there. Okay. Our position at the moment, and I fully support this position, is that it's not about controlling to the limit. If you implement good controls, if you implement the 8 principles of good control practice, if you implement the guidance that is there, you should be for most activities, you should be achieving exposures that are significantly below the current exposure limit. Okay. Now we'll move on to my own sort of personal opinions here. How much of our industry actually pay any attention to an exposure limit? So Eric's just talked great things there about the top tier construction projects, and I agree that the top end of the construction industry has moved on step change in the last 15 years. Most people working in the construction industry don't work in those top tier sites. They're working on domestic, commercial refurb jobs. They have no awareness what an exposure limit means at all. So changing the exposure limit will do nothing to protect people at that end of the industry. If you implement good controls, you should be below the limit. And certainly from HSE's perspective, we wouldn't be looking to take enforcement action using the exposure limit as a tool. We would be looking at the standard of control that was being applied. So there are arguments for reducing the limit, and I'm not going to go down them, but certainly if people focus on control rather than controlling up to a number, then that would be a better place for all of us.
Oh, thank you for that. Just two final ones before we move on to Eric.
Sorry, I was just going to say, I completely agree with Chris on, at the end of the day, the legislative requirements is to control because it's a carcinogen as low as reasonably practicable. And that will always, so somebody could meet the limit but not be controlling as low as reasonably practicable. And I think that has to be consideration. I noticed there was a question about the 15-minute workplace cell as well. With RCF, the main health concerns are your long-term. So generally 15-minute workplace exposure, your short-term exposure limits are to protect against acute effects. And you don't necessarily have that with the RCS, which is why the 8-hour TWA is the one that we work with, as far as I'm aware.
Okay, thank you. Just two final ones before we, because there's a whole wealth for at the end, and I'm conscious we get to Eric. Just a quick one from Carl. Hi, when would you recommend X-rays as part of the health surveillance? I know the miners' guidance is when you reach 75% of the workplace exposure limit.
I'm not a medic. It is covered in our guidance. HSE produce guidance specifically for RCS exposed workers. I think it might say in there that you should have an X-ray at the baseline. I could be wrong about that, but I think the X-rays then don't kick in until after 15 years of exposure. We don't recommend a numerical value if you're 3/4. I know where that came from. It used to call it the medical surveillance threshold back in old money. That's gone. If you are exposed to crystalline silica, then health surveillance needs to be provided. X-rays, I think, only start to become useful after 15 years, unless you've got people that are exposed at ridiculous levels, in which case, look at your controls. You know, X-rays are the least of your problems. I would have said that if you're in that situation.
Thank you.
I'll just very quickly add on to that. I mean, that's indeed kind of my understanding as well. Essentially, if you are high risk, it depends on your risk assessment. And whilst you can take indeed the exposure limit as a rough guideline for that, your where you sit against the exposure limit, but also bear in mind, of course, frequency, not just on a kind of a day-to-day basis, but multiple years. I mean, if you're exposed to, let's say, 75% of the exposure limit every day of your life for 15 years, absolutely, you should be doing health surveillance. For lower risk, then it is for kind of intermittent exposures, then it's not so much it's not necessary unless after 15 years. So it is, there's no hard and fast rule as it is. It is very much a case of not just what you're exposed to, but how frequently and for how long before you make that decision. So it's very much a case-by-case basis. There isn't a definitive answer.
Thanks, Eric. And then just the very last one for this session before we move on to Eric, from Mike. What did the recent HSE construction blitz discover with respect to controls, both on the engineering side and the respiratory protection side? Has there been any feedback on that yet?
That for me again. I'm not aware that there's been any feedback put out into the public domain, so I don't think we've discovered any huge improvements. My personal view is that the construction industry is not really improving, but you would have to wait for the official feedback to come from HSE. I've not got any inside information on that.
Okay, thank you. And with that, I am conscious there are a lot more questions, but we'll leave that to the end because I want us to conclude today in terms of having the very end of the presentation. So hopefully everybody can see my screen now. So it's a great pleasure now. We've introduced what RCS is. We've had how to control the exposure of it from a legal and practical perspective. And now it's my great pleasure to introduce Eric Ball from Park Heath, who's going to give us a real world case study on RCS control. So for those who are unfamiliar and for overseas, the HS2 project, which I'm sure Eric will introduce, is a major rail network project in the United Kingdom. So it's a huge infrastructure project. So Eric's background is an occupational hygienist with many, many years experience in complex infrastructure projects and global manufacturing organizations. He's helped to develop a wide range of tools for ergonomic risk assessment and occupational health audit. And as I say, today he is going to be talking about the HS2 project. So without further ado, Eric, the floor is yours, sir.
Thank you very much. That one. I trust you are able to see that okay?
Yep, that's come through.
Excellent. Right. Good morning, afternoon, evening, everyone. So my name is Eric Ball, a charter member of the Faculty of Occupational Hygiene, partner and occupational hygienist for Park Health and Safety Partnership. I will start off by disappointing you with regards to, I will be talking in relation to HS2, certainly. But I'm also going to be talking to you with regards to a kind of a broader scheme of how we go about managing not just RCS. We'll center it on RCS, certainly, but occupational health and hygiene in general. And the reason for that is because I spend a lot of my time across a wide variety of projects. I started in construction, major civils construction, all the way from the Olympic Park, working on the Olympic Park, and from working on there, we developed an understanding and a strategy by which we could really try to get a handle on what are our key risks in terms of occupational health, and in terms of making sure that contractors and the workforce are ultimately getting the protection that they need. So rather than pick one specific example, I could give you an example of, I don't know, how we manage tunneling underneath London, or how we manage tunneling or digging a big shaft, or when we have a particular issue with some of our concrete segments. And I could go into detail about that, but I think what would be more useful, or what I thought would be more use for you, would be to give you a larger, wider understanding of just how we manage it right across the project. And hopefully there'll be some good insight into how you might be able to take some of this away and implement it in your own organization. So I did split this down into a rough agenda. Obviously, as I say, I wanted to center on respirable crystalline silica. So I've got a couple of slides on that, but I think both Chris and Tina have done a grand job in terms of kind of setting the scene on that. I do want to firstly introduce what I mean by holistic health management, because that really kind of sets the scene in terms of not just the role of myself on the project, but the role of everyone, and how we make sure that every aspect of occupational health is captured and considered. And then I've picked out these 5 headings here: anticipation, recognition, evaluation, control, and assurance. I'm sure those 5 headings are certainly not going to be, both Chris and Tina aren't going to be strangers to those. When used to describe what an occupational hygienist does, quite often we would use those 5 headings as an example of what we actually do. And so I wanted to kind of say, well, how do I actually apply those principles on a project? And therefore, how can we show the various different elements of the project where we can intervene and help manage and reduce respirable crystalline silica exposures? So that's broadly what I'm going to cover. And the first thing I'm going to cover is what is a holistic health management. Fundamentally, we have spent most of our time, 95% of the time, we've been talking about the workplace. We've been talking about what work people are doing, and not only what they are doing, what they are potentially exposed to, and therefore what are the risks presented to them, what health effects could occur to them. That is very much what we consider the workplace element, the impact of the work on people's health. Holistic occupational health has to look at it the other way around as well, equally as well, which is the impact of the person's health on their work, whether or not someone turns up to work and they are fit for the role that they have, or whether or not they have any kind of pre-existing conditions which we might need to consider when we're going to be putting them to work. And it's very much a two-way cycle. A holistic health management program has both clinicians, so nurses or occupational health technicians who are clinically based and have a good understanding with clinical skills, teamed up with occupational hygienists who very much deal with the workplace element, and the pair of us working together to identify and understand what exposures are happening, what people can and can't be exposed to, what is the impact of their health, and both of them equally feeding into each other, one influencing the other and the other influencing them. The reason the reason I put this slide in place, and the reason that we kind of drive on this, because typically from an occupational health point of view, you find be it your organization, be it your project or whatever it is, when you think of occupational health, you think of a nurse in a room. And if that's your occupational health service, then you've only got half of the equation. Having an integrated service with both experienced hygienists and experienced nurses working together, that's really how you're going to make it happen. Now, for those of you in the UK, particularly who've worked in construction in the UK, or at least larger projects, might be familiar with the overall strategy that we employ. For those of you outside of the UK, this is a kind of fairly commonplace, and we call it the four W's, coined originally from the Olympic 2012 bid. When we were working on there, we had a clinical service and we had a hygiene service, and we both knew that they worked together, but it was trying to find out a strategy and a way in which both of them will become integrated and start to work together. The Venn diagram that you can see there, which I've pinched from the BOHS, that's the BOHS's version, but there are countless versions out there, was originally put pen to paper on that was in 2012, actually in terms of understanding how the key elements all tie together. Now, it started originally as a 3Ws program, a workplace and well-being. So the clinical aspect from the worker point of view, the hygiene aspect from the workplace point of view, and then a comprehensive well-being program tying all that in together. Now, to be honest with you, I would change this now. I would rather have the Venn diagram for just a well-being circle joining the health and hygiene together, but I would have the well-being program actually encompassing two. Do not underestimate the strength and the power of a good and effective well-being program, and I will touch on that right at the end of the program. The last W, which isn't on this slide, is the wider community. Right? Why am I talking to you now? It's all well and good me doing all this good stuff on our major projects, but how do we influence the wider community we're in? And our wider community could be the physical community we're in. It could be the community in terms of the family of the workers that are on the project. It could be the industry we're in. So I work, and most of my projects now are heavily involved with below ground work, tunneling specifically. So how do we influence the tunneling industry, or how do we influence the wider world, the wider construction industry? One of the reasons that I'm giving this presentation is very much that wider community program. It is the community of construction in general. This is what we do on larger projects. This is how we go about trying to manage these things. There are going to be elements here that you can take away, that you can put in place, that you might be able to start seeing this slow, steady improvement to try and reduce down these figures. So this is the overall strategy that we apply, and what I want to do now is kind of give you a bit more of a context in terms of how that actually works in reality. And I'll have a few examples from not just HS2. If you're unaware of what HS2 is, it's a high-speed rail 2, our second major high-speed rail network, which is running from, at the moment, London to Birmingham, currently under construction. And I work on a section of that. But that's not the only project that has implemented this strategy. As I say, it founded on the London Olympics, but various different projects throughout the UK have implemented it. So we have Crossrail, which is one of the new tube lines across London. Tideway, a large major sewer that runs underneath the Thames, applied this strategy. Northern Line extension, so an extension to one of the lines of the London Underground network. London Power Tunnels, so a new infrastructure to sync new power lines right the way around London, implements this as well. It's going to be used for new tunnel new tunnels underneath the Thames, again in London, for Silvertown and Lower Thames Crossing are both going to be implementing parts of this strategy. And the reason is because it works. So whilst I will have examples from HS2, just be aware that it's HS2 on their own and not unique in putting this in place. So before I go through the strategy, because we are talking about respirable crystalline silica, I will just kind of reiterate some of the stuff that both Tina and Chris picked up on. What is respirable crystalline silica? Why do we say respirable crystalline silica? I know all those three terms are very specific. Respirable in terms of the size. If it's inhalable, generally speaking, we would, if we breathe it in, cough and sneeze it out. We have mechanical means by which we can remove it. The respirable stuff, once it gets to the very base of the lung, that's the stuff that we can't get rid of. And we have to rely on our immune response to be able to try and break this down. And that's where the crystalline aspect comes into play, because if the silicon dioxide, a silicon atom with two oxygens on it, if that is an amorphous structure, then we're able to break it down quite easily. If it is a crystalline structure, then we're not able to break it down. It bioaccumulates, it stays within the lungs, and that's when we start to have our adverse effect, the adverse ill health effects. I have put, kind of at the bottom of the slide there, I've put in a link, well, not a link to a video, but a title to a video that if you really want to know the detailed chemistry of how this works, Professor Francesco Turci gave a presentation to a BOHS organized event called Inhaled Particles 2022. And anything that I talk about, he talks about in a lot more detail. He is a professor in chemistry, so you're going to need to have a desire to enjoy the science. But it's very well worth understanding then why this stuff accumulates or why we can break it down. So quartz is the second most abundant material on the planet. Why is that a problem for us in construction? Because you don't want to put expensive stuff in your concrete. When you are making concrete, you want to put in aggregate and sand, which is going to be cheap because you're making so much concrete. You don't want to be spending too much money adding in expensive elements. So we get whatever we can, and therefore, quartz being the second most abundant material on the planet, we put an awful lot in there. Obviously, if you start to then work on your concrete and start to breathe that in, you're producing respirable crystalline silica, then you are potentially being exposed to that, which can obviously have ill health effects. Some consider it to be the next asbestos. I've heard quite a few people refer to that. In fact, I would consider it the next asbestos myself. Obviously, asbestos causing asbestosis and silica causing silicosis. You know, there's a link between the name and the disease. That's not by accident. They are clinically different diseases, but at the same time very similar in a lot of regards. And obviously, if you are unlucky and once you've developed silicosis, you may well develop then into lung cancer as well. And as Tina correctly said, she identified, in and around 600 deaths a year in the UK. The World Health Organization suggested this was 2020 and 2021. In and around 12 to 13,000 people all around the world. So it is a carcinogen. We do have an obligation to, in the UK, we say, to control to as low as reasonably practicable. So linking back onto what the comment before or the question before with regards to exposure limits, frankly, it doesn't really matter what the exposure limit is. The question is if you have anything, it's too much. Are you doing everything you can? That's really when when I'm sitting down with organizations and projects, that's really kind of where I try to come from, is just say any is too much. And so we need to try and do everything we can to reduce it. A very quick side point is, and I'm mentioning this because I've heard it increasingly from a couple of people that who've obviously kind of read around a bit with regards to references to freshly fractured crystalline silica and whether or not that makes a difference. Fundamentally, or chemically speaking, biologically speaking, the answer is yes. Your real risk is associated with freshly fractured crystalline silica, and that's due to the chemistry of what happens when you break a crystal. And when the crystalline structure breaks, it reacts with water and actually creates chemical groups called, what are they called? Silanols, which actually then cause the ill health effect. Greater risk with crystalline silica, but it's worth mentioning that even with amorphous silica, if you start to use and abuse it, if you start putting saws through and working on amorphous silica, these silanol groups can also be created. And this was actually recognized when the World Health Organization originally said that that silica can cause lung cancer. They recognized that actually the level of carcinogenicity is inherent on the characteristics of the crystalline silica itself. So they did recognize that there were circumstances that even amorphous silica, which we might consider as low hazard, could become carcinogenic if we what we say freshly fracture it. That said, that's kind of a whole level of detail if you wanted to go into it. But fundamentally, crystalline silica, if you've got crystalline silica, if you've got quartz, treat it as a carcinogen, regardless of your of the source. So that's just a little bit about silica. What I want to do now is just kind of give you a story of how we intervene with major projects, and we've got various different using our anticipation, recognition, evaluation, control, and assurance steps that are well drilled into any kind of any occupational hygienist. And we'll start with anticipation. Occupational hygiene intervention at design is integral. In fact, it was Chris put up a slide with regards to talking about elimination, and she showed the slide with the a Crossrail health in design guide. Big chunks of that actually I was lucky enough to write myself, in terms of what opportunities can you take when you are designing a process that you will be able to eliminate these operations. Now, we can't eliminate the substance. It's unreasonable for me to come to any kind of major project and say, hey, I'm going to quadruple your costs because I'm going to tell you you can't put crystalline silica into your concrete. That's not going to happen. The amount of extra money it would cost it would make the project prohibitive. So we know it's going to be there. So what we don't do is eliminate the substance. Instead, we eliminate the processes where we can, to actually so we still have crystalline silica, but we're eliminating the processes where it becomes respirable. And we've got a couple of examples in these in this slide here. The context to it will be a bit difficult to work out, but actually I'm standing on the tunnel boring machine, the machine that actually makes the tunnel, and you can see a slight curvature to the tunnel lining. We produce tunnel segments, which we so as we dig the hole, we actually the tunnel boring machine fits segments into it. So these we make ourselves. We make in a big factory where we pour concrete into a mold, and then we put them in the tunnel boring machine to lift into position as we make it. And what you can't make out here, unless you've got very keen eyes, I'm going to circle my dot around this hole here and this hole here. Fairly innocuous holes. I know if you kind of look closely, you'd kind of think, well, what's the big deal with that? The big deal with that is this is one of the first projects I've worked on where I have been able to convince the designers to put these holes in place. These holes are there for tying in all of our structure, all of our fittings that we need for the tunnel. As we tunnel along, we need ventilation. So we need to fit ventilation ducting. We need water. We need power. We need a means by which we can get the slurry in and out. We need walkways. This means we need to have teams of guys traditionally drilling into the side of the tunnel wall to be able to then fit the brackets on that we're going to hang all of these utilities on. This was one of the first projects that I've been able to convince designers to actually include these precast fittings, and I'm quite pleased by it, just simply because particularly when you're talking to designers, one of the key things you need to do is have a good appreciation of what are the other demands on the project. So previously, engineers had very great concerns over whether or not having additional holes inside their segments would affect their structural integrity. We were able to convince them to kind of go back, look at the calculations. So in this regard, we could include these on here. And it might look fairly innocuous, but for me at least, a big step in terms of at least tunneling in the UK, getting precast fittings put into our tunnel segments. Of course, if we can get rid of the segments altogether. So another opportunity you could take is on the smaller diagram is where we have a tunnel. We may well have branches off or cross passages to join onto another tunnel, to join onto a station, to join onto a shaft. And where we've got these, we're going to, obviously we're making a tunnel out of concrete. We need to break that out to actually allow ourselves to dig through. This was actually from Crossrail, where we were able to anticipate where we're going to put the cross passage. Well, rather than have a concrete segment we have to break out, put a stronger steel segment in place, and then be able to, which allows us simply to lift out the central section, and then we can start mining through the ground ourselves rather than having to worry about breaking these out. So a couple of examples on a couple of different projects where we've been able to, by working with the designers and making them understand what the risks are, helping them be able to kind of eliminate some of these processes. That said, we've got an awful lot of concrete on our project. And in fact, most construction projects will have an awful lot of contracts. So inevitably, there's going to be a residual risk that needs to be managed on site. And this is when we start having the clinical team start getting involved. I'm sitting down with the designers, so I start understanding what is coming up, what kind of work is coming up, and therefore what kind of risks can we anticipate. where are we able to start anticipating that we're going to have respirable crystalline silica? I can pass that information on to now the clinical team, who then, when they start having workers coming through the door to work on that element of project, they can start saying, right, firstly, are they fit for the environment they're going to be in? It could be because we know that there's going to be dust there, so we need to know that we need to make sure that they don't have any kind of pre-existing conditions. This is also the first opportunity that we can say, well, we know that there's going to be dust in this environment. We know there might be some residual exposure, so we can start our health surveillance program here as well. We can start to say, right, you are going to need to have lung function tests. You're here in front of me now. We're going to make the appointment. You're going to be here in front of me in a year's time. We can also recognize that if there's going to be residual risk, we can start working with the construction teams in terms of saying, right, well, now you need to start thinking about working this into your risk assessments, but also start looking at different construction methodologies. If, for example, we failed for whatever engineering point of view to have steel segments in place, and in fact we're going to have concrete segments in place that need to be broken through, we'll say, right, fine, from a design point of view, we're going to have to break through this concrete. What kind of methodologies can you use to do that which don't introduce a silica risk? For example, you could use hydrodemolition, and in fact HS2 is using a big chunk of hydrodemolition to try and start to at least do a lot of preparatory work to prepare the surface and reduce down any kind of time that guys have to be on tools or equipment or using larger equipment to either break or prepare the concrete surface for the digging of the from the cross passages. I can't be everywhere at once. I can't, I am one person, one of a team of 3 to 4 people, but we've got a site of thousands of people that we need to try and pass this information on to. And so this kind of document here is what we call an essential standard. Essentially, this is everything we know about this particular risk. This is actually a single page of a 2-page document for just respirable crystalline silica, which we give to our engineers and say, we know this is going to be a risk. You might want to have a look at this. You might want to be thinking about, these are the different options in terms of kind of managing this risk. Very quickly, I won't dwell on this, but just to kind of say, we do try to go a step further and develop what this is a health risk assessment. It's an old version of a health risk assessment where we can be quite explicit in terms of having worked with the designers, worked with the construction teams in terms of what does the design say, what does the methodology, what methodology is being chosen, and we can then start compiling a health risk assessment to start informing where do we think extra controls need to be put in place, what controls need to be put in place, what monitoring needs to be put in place, what kind of health surveillance and training needs to be put in place. And actually, for me personally, or at least for Park Health, the health risk assessment pretty much governs a lot of what we do and how we interact with the project, because it enables us to kind of pass on all of this information. There are inevitably circumstances when things are things turn up that we aren't aware of. We have to then obviously kind of either react on the fly, or indeed we know what's coming up, but they haven't really kind of made a decision in terms of what kind of level of control we want to put in place. Now, the picture at the top right there, this is called shotcrete. I believe in the States you would call it shotcrete. We would call it spray concrete lining, SCL methods, or if you're in Europe, the new Austrian tunneling method, the means by which you are spraying concrete. Now, spraying concrete is a pretty grim business, as you can imagine, very noisy and very dusty. What has been a nice, interesting step change for the tunneling industry, particularly kind of from the lead tunnel, so kind of from about 2010 onwards, the means by which are the accepted standard of control for this operation from about 2010, 2012 onwards has been the use of powered air purifying respirators. it's universal now. Before then, it was standard. Someone would be given just a normal dust mask. But obviously now the dust mask would have the technical capabilities of achieving a right kind of fit, but these guys have to wear them for a long period of time. When the powered air purifying respirators come on board, they were very quickly taken up by projects like Lee Tunnel and then Crossrail, and it's become the norm. Now, you wouldn't find spray concrete lining occurring in the UK without it. And one of the reasons for that is because the guys won't have it any other way. They have had a little taster of a good level of control for during spray concrete lining, and they're not going back. And I've heard of when a spray is due to happen, and their powered air respirators for whatever reason weren't working, they just stopped and said, "Well, I'm not doing it if I'm not able to use my powered air." Obviously, it's all well and good having these in place, but just be aware that obviously you have to maintain those. They all come with, for example, a flow testing kit. Make sure that you the guys are aware of how to use that. We've made a mention of obviously face fit testing, because not everyone wears a powered respirator. If you're standing further back, you're not going to be able to. You might just use a typical FFP3 respirator, in which case obviously you need to be face fit tested for those. I won't dwell too much on kind of various other types of control we put in place, but this is all very much residual exposure. We have tried to reduce the exposure by eliminating the process if we can't, making sure we choose a methodology which is going to reduce it even further, and then we start looking at and then putting kind of either ventilation or extraction or damping down systems in place. We only use PPE to control that residual exposure. In fact, with spray concrete lining, your dust levels can be such that actually you're going to have an extreme a dust exposure which is far in excess of the capabilities of a respirator. For that reason, we have to use engineering controls, ventilation and dedusting equipment to reduce the exposure down, not completely, you can't do that, but down to a level at which the PPE is going to work. Very quickly, for those of you in the UK, and I wouldn't be surprised if it was required elsewhere, our extraction system, on-tool extraction systems are considered as local exhaust ventilation. For that reason, they do require a thorough examination and test. That is not necessarily, well, it does include your daily checks to make sure it works, but actually there has to be a thorough check in terms of flow rates of it, making sure alarm systems work, and that the whole system works as it should do. So it's just worth me mentioning there that there is a requirement and expectation for that. I've talked now for 28 minutes and I haven't yet mentioned the standard thing that occupational hygienists do, which is to make sure that we measure it. Measuring, as Chris said, is not control. As I say to most of my projects, if they ring me up and say, "Eric, I need you to come down and do some dust monitoring because we've got a dust issue," then I won't bother doing the monitoring. You have a dust issue. You've just recognized it yourself as low as reasonably practicable. What are you going to do about it? Because I'm only going to come down and do the monitoring once we've agreed that you're going to put additional controls in place. But this is the point at which obviously we can work out what kind of level of risk is silica, where is it a risk. 2 examples of spray concrete lining there, where we identify what is the risk to the individual undertaking the work, but obviously there's teams of workers further back. What are the risks to them, and at what point can we start either kind of elevating or alleviating the level of the requirements for either ventilation systems, or do we have to change those, or do we actually can we alleviate the needs for respiratory protection? Using the monitoring is quite a useful tool for us also to start looking at the balancing of ventilations. If you've got a tunnel here, quite often it's a dusty job, so someone says, "I'm just going to flood it with air." The trouble with that, of course, is that you just push the dust further back, you expose more people. So using our monitoring to be able to inform construction teams to say, actually, there is such a thing as too much air, and actually where you place that air to actually form a plug to give the guys enough air to breathe, obviously, because that's going to be concern number 1, but 2, to try and use it as a barrier to prevent air extending backwards. I want to talk about assurance because this, again, is when the next step of clinical comes in. Now, all of the time, we're constantly talking about to the clinical team to say, hey, these are the dust issues that we've got on site. These are the areas where we've got respirable crystalline silica. And that alerts and these are the levels that we're seeing and the people being exposed, alerting the clinical team to be able to intervene and start performing health surveillance on the people. And then it will be between us in terms of understanding levels of exposure, frequency of exposure, to then understand and decide whether or not we need to go beyond simple lung function and spirometry and go into X-rays. If you have a clinical team, please open it up to drop-in treatment services, because clinical teams, because it's a clinical setting, people say a lot more in a clinical setting than they would do openly to managers and supervisors. You get a lot more truth, particularly when they're talking about health issues in the workplace. And quite often we get very good feedback from people who have just dropped into the clinicians, had a discussion with them, and they've said, oh, they've got a particular concern about dust in a particular area. And then the clinicians say, well, do you mind us sharing it with our occupational hygienists? Anonymously, but just to kind of say, so they don't feel like they're grassing up, because that is an issue sometimes, but giving them an honest appraisal of their personal opinion of the workplace, so that we can go out and start actually looking and start intervening, both with regards to evaluation and establishing a level of control. We don't necessarily always have to go out and measure it. We can do semi-qualitative and quantitative means. This is a chart that we use. Actually, if anyone is from Finland, you'd see a version of this. It's called the TR system in Finland. This is an adaptation of that we took and applied specifically to occupational health. So we could try and have some kind of quantitative analysis of just doing a site visit. What's good, what's bad, what's right, what's wrong, and therefore understand, okay, where do we need to prioritize things? Well aware of the time, and be thankful to know that this is my last slide, and this is the wellbeing program. Why is well-being so important? I'll be honest with you, when I started in occupational hygiene, I thought, well-being was the nice to have. It was the fluffy rainbows and the nice softer edges. But actually, the more I've worked in this for over 15, 17 years, a strong well-being program actually governs everything, because you want the guys and girls on site to actually be telling you the standards that they want. How do you drive change? How do you drive improvements? Well, we see that, for example, let's take powered air respirators. We on one particular project, not HS2, we had a group of guys led by one who kind of came up to us and said, the conditions down there aren't good enough. We're not happy with P3 respirators. We want powered air respirators, just like the SEL team have. And when we were kind of, having a discussion with him, it goes, one of them said he had changed his life. He had engaging with wellbeing programs on the projects he worked. He had given up smoking, had given up drinking, gone to the gym, and he changed his lifestyle to being, a full-on fitness freak. And to which he said, I put all my time and effort in to look after myself at home. It's time for you to put the time and effort in to look after me while I'm at work. And that really struck with me, and it struck with the rest of the team in terms of actually the strength of a good wellbeing program. Giving workers the opportunity to take care of themselves then puts them, it means that you're not fighting them to wear a dust mask. They want to wear the dust mask because they're going to the gym to look after themselves outside of work. They want to look after themselves inside of work as well. So yeah, a good, strong wellbeing program, well worth having. And extend it beyond just simple posters. Make it engaging. Make it something that the guys actually want to take part in. And that's the end of my slide. So thank you very much.
So many thanks, Eric. That was a whistle-stop tour of what is quite a challenging process. I've got a question to start off with whilst everybody's digesting. With a program of that magnitude, So when you're talking about individual companies working and providing health and safety requirements and protection for their individual workforces, when you're involved in a project that big, so with the concrete spraying, for example, because you've got different companies involved in that process, and I don't want to turn this into kind of a legal kind of scenario, but how does that work from a engineering control and risk management when you've got so many companies involved?
So you have the principal contractor right at the top. So let's just take, I don't know. Let's think about. Well, let's take HS2 for example. So you have the client at the top. They set the standards. They employ and direct. It was Chris that actually mentioned this with regards to the CDM regulations. It's all structured in there. The CDM regulations will then say, right, you have to have a principal contractor. That's aligned. They stand over everything to say, I'm going to build this, and I'm going to bring in all the contractors, all the relevant people to do that. The principal contractor has principal control and principal responsibility, and it's at that level that I sit alongside the principal contractor. The thought process in major projects is that we will provide the opportunity and the circumstance and the service to our subcontractors doing the work to establish a level of control and everything you need to be able to do it properly. So, for example, when I am working on HS2 and I am working for a line, whilst I'm employed directly by Park Health and Safety Partnership, actually I regard myself as working on a line. Anything that I do on the to the benefit of the line, but actually for the subcontractors. And in fact, a lot of the engagement, let's say I do some monitoring. If I do some monitoring, I will write that report. Whilst it's written for a line, it will be for the subcontractor. Take this away, use this, not just for your project and the improvement on your project here, but actually when you go off somewhere else, this information is valuable there as well. And I always make sure I present it in such a way that it's not just what are you going to do on this project, but what are you going to do elsewhere as well. All part of the strategy of wanting to improve the wider community, and the wider community in that regards is our subcontractors. There is just a caveat on that, depending on the project. Clinically, we can provide it should we want to, but one of the challenges with regards to health surveillance is actually this kind of should be provided by employers, because they're able to track records a lot better than us. What we don't want to do is have a whole load of clinical information that is just relevant to our project. It's actually more relevant across the whole of an employee's kind of lifespan. So, health surveillance over 5 years is irrelevant. You want health surveillance over 15 years. So we, in that case, whilst we can provide clinical services, we do push on contractors to undertake it themselves. And then we have an assurance program to make sure it's done and make sure they've got all the information they need to inform their own health surveillance program.
That was brilliant. Thank you. I'm just conscious of time now. And just to bring in Chris and Tina, because we've had a couple of questions from Robert, and it was just some observations from mine as well as Eric's presentation, especially some of the graphic pictures. Robert said around the money expenditure over type fitting and fit testing has not really been that effective when you consider the HSE statistics for deaths over the last 10 years. And when you couple that in with the HSE's bulletin on the 20th of September around not using H&S legislation to require workers to be clean shaven because alternative loose fitting solutions are available. I'd like to know the team's thoughts. And again, this is my observation, Eric. I'm going to start with you. It looked in your presentation that there was a kind of a move towards loose fitting head tops with powered systems. Do you see within your well-being, which I think is a great thing, within your kind of well-being programs, that there's almost an inertia towards loose fitting as opposed to tight fitting respiratory protection?
I would say, as a broad, a rough generalization, from the Olympics, it was a rarity. To Crossrail, it was very specific to one particular operation, and then going through Tideway, Northern Line expansion. I would say probably it's now a 50-50. on some of my projects. There is a recognition that these things do cost and they do need managing, and also there isn't a big favour to have communal aspects, like communal units. It has to be kind of individual units. But I would say in the circumstances where we have to use a dust mask or some kind of respiratory protection on most of my most mature projects, I would say it's about a 50-50. And it's not just sprayed concrete lining, of course, or dust particulate. It's also welding operations as well. We are seeing that increasingly as a set standard, mainly because when we start early, we do set the standard. There is no surprise when someone turns up and says, I want to do this. It'd be like, well, here's the standard you have to achieve. Yep. And that has powered respirators in there.
Chris, Tina, I'd welcome your thoughts around kind of the move towards looser fitting, and especially in mind with your comments, Chris, around engineering controls as low as reasonably practical, so that literally the RPE is the last around residual risk that's left after you've put your predominant engineering controls in place.
Shall I go first?
Go on, Tina, yeah.
Well, basically, when I worked for a large steel firm, and one of the specific projects that I led was looking at exposure to carcinogens on coke ovens. And it's recognised on coke ovens that you have to use RPE. It just is what it is. So we did a variety of looking at different tasks, different activities. We did some ergonomic approaches, and we worked one-on-one with the workforce. And what we found was that in the long run, the loose-fitting RPE is obviously a winner. It's more acceptable for wearing, and you don't have the worries about around failure of face seal dependent masks, etc. But what we did find in particular, the biggest barrier was changing people's perceptions and changing the attitudes. And it took a lot of work. It's great to implement RPE, but then you've got to actually put all the other things in place around it, which does take time and effort. And it's trying to get engaged with the workers to get them to change, because it's subconscious attitudes that you're working with here. So it can be quite difficult. So I do think that loose fitting, so powered respirators are a much better option. And as has been said already, in the long run, you've got some cost-effective options there. But there is a lot in the background that people need to put into place as well. So that's my thoughts on that, if that helps at all.
Thank you. No, that's really good. Thank you. Chris, any thoughts?
Not much to add, really, other than something that's just occurred to me as Eric was talking then about the rise in the prevalence of powered equipment. Our definition of reasonably practicable will change over time. And whilst 15 years ago, we would have said that powered equipment is not probably not reasonably practicable unless you've got an extreme exposure scenario. The more it becomes the norm, the more it becomes established, at some point we will consider that it is reasonably practicable for that to be the standard RPE. We're not there yet, and that, I'm not a lawyer or a judge. I can't define reasonable practicability, but standards will change over time. And as more of the construction industry demonstrate that it is reasonably practicable, at some point it will become the norm. We'd all like to see it become the norm, wouldn't we? That's what we'd like to see. We know that disposable dust masks don't protect in many cases. They do have a part to play, and they're not comfortable. When you've got workers wearing RPE for several hours a day, you shouldn't be wearing a disposable for more than an hour at a time. It's just, I've given dust masks out to people in the audience when I've been doing presentations and said, stick that on and tell me when you get uncomfortable. And they've put their hand up after less than 10 minutes and they're sat down in the audience. They're not doing a heavy job on a construction site. They are not a great solution at all. We'd love to see powered RPE becoming more prevalent for all kinds of reasons.
Brilliant. Thank you, Chris. Just one more from the attendees. So this is for Eric. How do you inform the occupational health physician about workplace risks? Do you use a standardized document?
So in terms of a standardized document, most of the kind of formal reporting, which is open for everyone, is done on the health risk assessment that I quickly showed. That kind of gives a good understanding of not just what we believe to be required, but also kind of the controls and also what does the contractor agree if it's going to be done by a contractor, what are they actually going to do about it? So the health risk assessment is the main formal document, but it kind of goes back to the holistic occupational health point of view, which is both the clinical and hygiene team are so integrated that it's regular and routine conversations. Quite often we're working in the same office next to each other, and I'll say, oh, I've just got the lab results back. Hey, the guys in the segment factory have a very high silica exposure. You're going to need to include those on health surveillance. And then I'll just say, I'll be like, right, you need to speak to, and I will tell them, these are the people on site you need to speak to, specifically managers, supervisors, to group them together. If we've identified a particular group, then we will probably, let's say, a particular shift or just a particular section of group workers, then we would involve either the shift engineer or the construction manager to say, look, these guys are doing something unusual. They need to be captured as well. In terms of the main document that we would use to record where health surveillance is performed, is that overarching health risk assessment, and that can be an overarching document for the project, or it can just be for an individual process, and that generally kind of tracks the kind of monitoring works, training works, who needs training, who needs monitoring, who needs health surveillance is kind of governed by that.
That's fantastic. Thank you. In the interest of time, I'm going to draw. There's no more questions in the Q&A other than a lot of, they're not really questions, they're just comments to both Tina, Chris and Eric. Everybody said how much they've enjoyed the webinar. So a very big thank you to you all for your efforts today. Just from my side as chair of the section, when my laptop will wake up. So just moving, a couple of people have asked, the next webinar is on the 24th of November on welding the multi-hazard process. The registration will be available from tomorrow. We have keynote speakers from the European Welding Federation, 3M, and the Breathe Freely campaign that was mentioned kindly by Chris earlier. So if people are interested, we will post it on LinkedIn as well as the ISRP Europe and the main ISRP website tomorrow. So if anybody's interested in membership as well, please go to the website. We're always looking for new members. And also a big thank you to the British Occupational Hygiene Society, of which Tina and Chris are very active members, as well as Eric's involved in occupational hygiene. Chris is the president. For those from abroad and our European colleagues, even though it's the British Occupational Hygiene Society, please look on the website. There's lots of really, really useful information in there around many different topics that might be of use. And then just finally, we did advertise an asbestos webinar for December. We're not going to do that as a webinar. We're looking to do that in conjunction with BOHS in the early new year as a face-to-face event. There will be a virtual element for those who can't attend because they're overseas. So please watch out for that on the ISRP website. And with that, I will draw to a close today's webinar. A big thank you again to Tina, to Chris and to Eric for 3 fabulous presentations, and also to the 97 attendees from today. It's been a great pleasure to deliver the webinar to you, and I hope you've thoroughly enjoyed it. And with that, I will wish you a good rest of your day. Thank you very much.